So we already learned about this private queue example. So in the real life, we have many applications. For example, the options. And then let's say if you go to one kind of government office, so maybe old people will be priority, or young disabled person will be priority. So we can put the number smaller. So the person can be in the first queue instead of the normal people. So that kind of things happens in the real life, and we can use this priority queue. So the keys in priority queue can be arbitrary objects on which an order is defined. So if you use number, so we can look at the smaller number as the priority. If you use the alphabet A, B, C, D, E, then you can think that A is the minimum and Z is the maximum. So it depends how you define the keys. So two distinct entries in the priority queue can have the same key. So it will be very challenging if there are the same keys in the items. So that's why there is a kind of rules, we call it the total order relations. So the total order relations, it gives you some kind of condition. When we do the priority queue, we can have this kind of properties. So the mathematical concept of the total order relation, we call this is the which comes first. So the reflexive properties means if x is first than x, so it means like the p of the x is equal to the x, then it means both of them are the same. We can also have the anti-symmetric property. In the anti-symmetric properties, if x is coming first then y, and y is coming first then x, then we can say that x and y are same, because this is the anti-symmetric. We can also have the transitive properties. If x is first than y and y is first than z, so I can say that x is first than z. So this is the total order relation for this priority queue. We can see the pattern. Okay, we call this is the composition design pattern. Okay. So the item in the priority queue is simply a key value pair. We have key and we have value. And the priority queues store items to allow for efficient insertion and removal based on keys. Yeah, so this is the two basic operation whenever we have the data structure. So if we can create the class, this is the class priority queue, and we have the class item. The class item, we can define the items with two kind of properties, which is key and value. So when we construct, we call this is the constructor of the class, we have k and v, and then we can check whether it is less than. So if the key is less than the other key, so it is to compare. which one is the first and which one is the later. And then we have the is empty, whether the priority queue is empty or not, and so on. Now, when we have the priority queue, there are some guidelines how we can implement it. In the example that you saw before, whenever we have a new item, we will sort. So when we have 5, so yeah, we just put into the priority queue. And if we have another item, 7, so we need to determine where will we put the 7? Will we put here or will we put here? So we need to do the comparison. And then, okay, I know that 7 is later than 5. So this is 7. Then I have 5 and then 7. And then I have 6. So I need to check where is the location of 6. Whether I put here or I put here or I put here. So there are some ways to do this kind of storing. The first implementation is with an unsorted list, and the other is with sorted list. The meaning by unsorted list, we can just add the element. So let's say now I have the key is 4. Okay, I add 4. And then I have the key 5. Okay, I put 5. And then I have 2. Okay, I put 2. I have 3. Okay, I put on the last element 1. So I put on the last element. So it is similar with Q. So the common Q. And then whenever I want to remove, so if I do it this one, the add will be O1 because I will just put the element at the end. Because we can insert the item at the beginning or the end of the sequence. So it is one operation. But whenever we want to remove it, or I want to check the minimum, then it will take O(n). Since we have to traverse the entire sequence to find the smallest key. So I need to check where is the minimum one. Okay, the minimum is at the end. So I need to go from the first, check. Okay, this is the small item. So the big O, the worst case is O(n). We can do the implementation with the sorted list. It means whenever we have the new item, when we add the new item, we will sort it. So we want to find the place where to insert. Let's say I have 4. Okay, you can just put 4. And then I have 3. So as I mentioned to you, we can determine whether 3 is located in the before 4 or 3 is located after 4. So the add operation will take O(n) because it will check every element first before we put that element. However, if we sort it first, the remove min or finding the minimum will be O(n) because I know that the smallest element will be the first. So since the smallest key is at the beginning. So it depends how you can implement and what is the most common operation in your data structure. If we are doing the unsorted list, so this is the unsorted list implementation, the unsorted priority queue. in the find minimum of the unsorted, we will check first whether it is empty or not. If it is empty, then priority queue is empty. But if it is not empty, so let's check the small. The small is the first data. So after we assume that the first data is the small, and then we want to walk, or maybe we can say this is the iteration. The walk is we want to check what is the item after the first element. So if walk is not known, it means if the next element is not known, then we will check whether the element is the element smaller than the small. If it is smaller, then let's change the small with the current element. And then we go to the next element. We go to the next element until we finish, and we will return what is the small element. So if we construct this one, we will use the positional list. I guess you already know, we learned the positional list last time. And then we want to check the length or the elements, the number of elements in the list. Add, yeah, in this case, because it is unsorted list, so we just add at the last. And if I want to check the minimum, so I will call the find minimum function. So I use the find minimum to check what is the minimum value, and then I will get the minimum item. If I want to remove the minimum, again, I will call the function find minimum, and then I will remove it, or I will delete it. If it is sorted, then whenever you add the new element, so you are going to make a new element, which is the constructor, make a new instance, and then let's say that the walk is the last element, and if the walk is not known and the newest is less than the last element, and yeah, you can just put walk is before the walk. So it will be a kind of loop. So it will be a loop from the backward. We will check for every of the element from the last element, and then if it is located in that particular position, so we can just put it in that position. So if walk is known, then let's put in the first element. If it is not, then let's put it after the walk. So this will be like n time, because we will do the loop until the walk is known. So until the first element, because we are going to do the backward. If I want to check the minimum, then I will just call the first data. And if I want to remove the minimum, it's also the same. I will check the first data, which is the minimum. So this will be ON, and this will be O1. In order to do the sorting, okay, so we can have many sorting algorithms for this one. So we can use a priority queue to sort a set of comparable elements. It means first we can insert the elements one by one with a series of add operations, and then remove the elements in sorted order with a series of remove min operations. So the running time of this sorting method depends on the priority queue implementation. So I just give you the very simple sorting problem here. I guess in your team project, some students want to apply the sorting algorithm. You can look at the kind of algorithms, which one is the best one. Oh, by the way, I give you another comments to your team project. Okay, so if you are the team captain, please check your team project section, and I think you can stop. Please look at my comment, and then please do your project according to my comments. If you have any question, please feel free to send me email. And I think we will meet in the next 2 weeks or 3 weeks. So at least you will meet me one time. So you can start from now to design your algorithm to make the small example. I think most of the teams, you don't provide the small example. So I still cannot figure out what you will do on your team project or something. Please, in the meeting with me, please show some small example so you can solve the problems easily. Okay. So in this case, I'm using the very common sort. This is the priority queue sort, and then we have the S, which is the sequence, and then C is the comparator. So whenever we have the algorithm, we will have input and we will have output. And this is the process how you can handle the input so that you will show the output. Let P is the priority queue with comparator C. And then while S is a sequence, and if S is not empty, so this symbol is negation. If S is not empty, then let's remove the first. And the first element will be E. And I will add into the P. So I will add into the E for the element E. So this will be a loop. And after we finish the loop, then we will back again to the S. So if P is not empty, I would like to remove the minimum, and then I would like to check the key and put into the E, and then E will be added into the last of S. So I'm going to use a selection sort for this one. So the selection sort is the variation of the priority queue sort, where the priority queue is implemented with the unsorted sequence. So unsorted sequence means when we try to apply the priority queue, we just make the sequence 4, 5, 2, 3, 1 without any sorting, and then we will sort it after we want to remove it. So the selection sort here, first we will insert the elements into priority queue, and we will do the insert operation that will take n times. So if we use the selection sort, we will do the insertion with the O(n) times, and then remove the elements in sorted order from the priority queue with n remove min operations, and it will take also n times. So the selection sort, it will run n power of 2. So let's see this example. I have the following sequence. 7, 4, 8, 2, 5, 3, and 9. And then I have the priority queue, which is an empty. So in the phase 1, I would like to check for every of this sort. Okay. So I'm going to sort it. Okay. So 7. Okay, I will put into the priority queue. And then 4. Okay, I will put in the last of the priority queue. And then 8, I will put it after the last of the priority queue. 2, I will put on the last. 5, I will put on the last. 3 and 9. And after I have this one, this is unsorted. And after I have this priority queue, I will return back to the sequence by looking at for the small element. So after I check for every of this element, so I know that the 2 is the smallest. So I will remove 2 from this priority queue and then put it into the S. And then I will check what is the smallest element here. So I know that 3 is the smallest element. So I will put it into the last of the sequence. And then I will check what is the next smallest element, which is 4. So I will put 4 as the last element of the sequence. And so on. So we will have the sorted after we put the elements all in the priority queue. So this will take n power of 2 because I will do the loop for every of this element, and after I remove to this priority queue, so I'm still checking what is the smallest element, so I can remove it to the sequence. Another kind of sort is insertion sort. Insertion sort is the variation of the priority queue sort, where the priority queue is implemented with a sorted sequence. So the name is insertion sort. It means whenever we insert an element, then we will sort it first. When we implement this one, the inserting elements into the priority queue will have an insert operation that takes time proportional to this one. And then removing the elements in the sorted order of the priority queue with a series of n remove operation, it will take also on. So the insertion sort will run on power of 2. So this is the sequence here. You have the 7, 4, 8, 2, 5, 3, and 9. And then when we try to use the priority queue, so I'm going to check the first element, which is 7. So I remove 7. And then I put it into the priority queue. And then now I'm checking 4. So 4, I will check where is the good position of 4. And I'm checking from the last element. 4 is smaller than 7. Yes. So I will put before 7. And then I will remove 8. This is the first element here. And then I will check. 8 is smaller than 7. No. Then I will put it in the last element. And then I will check the next element, which is 2. So 2, I will check. 2 is smaller than 8. Yes. And then I will check again with 7. 2 is smaller than 7. Yes. So I will check next element. 2 is smaller than 4. Yes. Then I will check. Then we have nothing before 4. So we put 2 before 4. And then we will again check the next element, which is 5. 5. Is it smaller than 8? Yes. So we will go to the first and the next element, 7. 5 is smaller than 7? Yes. Okay, we can compare with this one. 5 is smaller than 4? No. Then we remove the 7 and 8 to the backward, and then we put 5 here. And so on. And we can get the result as the insertion sort like this. And if we want to move back to the sequence, so we will just get the first element. The first element, which is 2, and then the next first element, which is 3, and the next first element is 4, and so on. So this is the classical implementation for the paradigm. There can be another kind of insertion sort. We call it the in-place insertion sort. The in-place insertion sort means instead of using an external data structure, so in the previous one, we have S and we have P. So S means we have the S is the sequence, and we have P. Okay. We have P to represent the priority queue. So for the implementation, we use two kind of data structure. Let's say that the sequence is a list, and the priority queue is another data structure. But we can just use one kind of data structure. So instead of using external data structure, we just implement the selection sort and insertion sort in place. In place, it means we just use a sequence and then replace or swap the element. A portion of the input sequence itself serves as the priority queue. So let's say I have the 5, 4, 2, 3, 1. Then the in-place insertion sort means we keep sorted the initial portion of the sequence. So we will keep this one. And then we use swap. Swap means we change the position. So I will check one by one. I will start from the beginning. 5 and 4. So is 5 is higher than 4? Yes, because 5 is higher than 4, then swap. So 4 and 5 will be swapped. And then after that, I will check 5 is higher than 2. Yes, then swap. And then we will check again 2 and 4. Okay. 4 is higher than 2. Swap. And then we will check 5 with 3. So 5 is higher than 3. Yes, then swap. And then we will check if 3 is higher than 4. 4 is higher than 3. Yes, then swap. 3 is higher than 2. No, then put this location. And then we will check 5 is higher than 1. Yes, so swap. 4 is higher than 1. Yes, then swap. 3 is higher than 1. Yes, swap. 2 is higher than 1. Yes, swap. And at the end, we will get this one. So we just use the swap operation for this in this insertion swap. So we don't use the sequence and we don't use the priority queue. Okay, so that's the priority queue. So let's move to the next section. Now we are going to discuss about maps and dictionary. So as I mentioned before, we have the curly bracket. So the curly bracket, we can use it for set and we can also use it for dictionary. So the Python has a very good data structure in dictionary. In other kind of programming language, they also have the structure like dictionary and terminology. Usually they use it as map. So let's see what is maps and what is dictionary. Instead of dictionary, we can also use map. Map and dictionary, actually they are the same keyword. So with a map, it is a searchable collections of items that are key value. We have key and we have value. And the main operations, now there are more operations, which is search. You know, the two basic operation is insert and delete. But in the map or yes, some other kind of function like list, we can also have search function. In the map, multiple items with the same key are not allowed. So when we use the priority queue, in the priority queue, multiple items with the same key is still allowed. But in the maps or in the dictionary, the same key are not allowed. That's why when you do with the Python, when you have the same key, then it will be error. So the application is something like, yeah, like the address book or dictionary, such on. So one word will have meaning. Even though you can say that in Korea, let's say bear. So one word can have several meanings. So yeah, you can say that this is the key and we can put several meanings as a list. Student record database. So every student will have a unique student ID. So we can put it as a map. So in the Python, we have the dictionaries. So dictionary class, dict class is is arguably as the most significant data structure in the language. So if you can apply the dictionary in your team project problem, that will be very powerful. So it represents an abstraction known as dictionary, in which unique keys are mapped to associated values. So if you are doing with the shortest path problem, so you need to define where is the location or what is the position. If you still remember the first problem in our data structure, we have the problems. We want to go from house to school. So it means the key is house, another key is school, and another key is police office, another key is map, and etc. Here we use the term dictionary when specifically discussing Python's dictionary class, and the term map when discussing the more general notion of the abstract data type. So when you use Python, Python will use the term dictionary. But if you are using different kind of programming languages like Java, in Java they do not use dictionary, but they use map. So if I use map or dictionary, it means they are the same. Okay. So let's just use map for the general terminology. Yeah, map or dictionary, they are the same. And in this case, there are some kind of syntax that you need to understand. I want to check the MK with the square bracket. It means I would like to return the value of the associated EK. If I use MK equals to V, then I would like to assign this V into the value of the key K. If I want to delete the K, so I can just say delete MK. If I want to know how big are the items on the M, so I can use length. And the iteration means I want to check for every element in the map. I can also check whether the key K is in the map or not. So it will return true. And then I will like to check if I want to get the K. So it will return MK. It means I will get the value of the key K if the key K exists in the map. If K is not exist, then it will return the default value, which is no. I can set the default value for any K. So if K is existing in the map, then just simply return MK. But if K does not exist, then let's set the MK as D. And then you can use pop. It means you want to remove. To remove the item K if it exists in the map. But if it doesn't exist, then we will put as no. If it is pop item, then we will remove arbitrary. Arbitrary means random. Okay. Any item, it will be removed. Clear means remove all key pairs from the map. If I want to check the keys, then I would like to make a set of the key. If I want to check the values, then is a set of all values. If I want to check the items, then I would like to check the set of K, B. If I want to update, so I would like to check, I would like to make the MK, M is updated with M2. So the mk, which is equal to v, it will be now updated with the m2. M equals m2. So it will return true if the map in M and M2 have identical key value association. And M not equal to M2, it will true if it is not identical key value relationship. So this is the example. Let's start with M empty. I have K as the key equals to 2. So K equals to 2. I have B and the value is 4. So B equals to 4. I have U equals to 2. U equals to 2. So whenever we input or whenever we insert a new items, it will be at the end. I have V equals to 8, so it is the end. Now I have K equals to 9. What is K? I know K is available in the map. So I will just change the value from 2 to 9. And then I have B, MB. I would like to know what is the value of B. The value is 4. I want to know what is the value of X. Is there any X? No X. Then it is L. I want to get F. Is there any F? No. Then it's no. I want to get F equals to 5. Is there any F? No. But because I specify 5, then the return value is 5. I want to get K equals to 5. Is there any K? Yes. So the value will be 9 according to the value of K, not 5. Let M. We have 1, 2, 3, 4. Delete MV. So I will delete the key B. Top K. So I will remove K. Now the keys are B and U because we have only this one. What are the values? We have 4 and 2. What are the items? We have just 2 items. If I set the value B, comma 1, so B actually it is 4. So I don't need to change anything. But if I set the value A equals to 1, I will insert A equals to 1 into the map. And then pop item, I will just remove any random item from the map. Okay. Oh, sorry. I guess this is the time.